All right, welcome to the review practice quiz. Number 1, evaluate. So that means find the answer. All the students know the exponents E-I-E-I-O. So the bottom of the fraction is called the index and the top is the exponent. The index means 3. Take the cube root, which is 2. Cube root of 8 is 2. Then I square it. Or you could square it first and get squared 64 and then do the 1/3 power, which means the same thing as take the cube root of 64, which is 4. You get the answer either way. When you divide like bases, you subtract the exponents. 20 minus 22 is -2, and that's okay. So we cross the line, change the sign, and we get 6 squared, which is 36, 1/36. Here we think about our perfect squares, 1, 4, 9, 16, 25, 36, 49. Aha, 49. 49 does go into 98, so we go square root, square root. This is called simplest radical form. 49 times 2 makes 98. Take the square root of 49, you get 7 radical 2. Simplify. Follow the order of operations. We're going to cube this stuff first, then figure out the rest of it. So it's 4x squared. We're going to cube the 2, which is 8. We're going to cube the cube, which would be multiply. We have power to a power, you multiply the exponents. So we have 3 times 3 is 9. Then when we multiply like bases, we add the exponents. So we get x to the 11th. And then 4 times 8 is always 4 times 8. Because those are numbers, right? So the numbers are numbers, you do number things with them. The exponents, you follow the rules of exponents, so 32. When you square something that's a binomial, you write it down twice, and you got to FOIL it out. You can't just square it because it's the subtraction there, or addition. You're not allowed to distribute exponents over addition or subtraction. So this times this is 4x squared, this times this is minus 2x, this times this is also minus 2x, and then this times this is plus 1. So it's 4x squared, like terms, minus 4x plus 1. Factor, 2 sets of parentheses, 2x and x. So 3 and 1 is the only way to make 3. I got to put 3 opposite of the 2 to make that be 6, and then the 1 goes here. So that's how that factors. Now to check your work, we're going to make sure that it works out to the center, so 1 and 6 do make 7, so that is the correct answer right here. The red part is just me checking it. Factoring by grouping. We group the first 2 together and the last 2 together. We take out the GCF. We're left with x plus 3, x plus 3. Then we notice that, ooh, these are the same. So then this yellow thing and this yellow thing here get factored to 3 to the front. X squared plus 2 is left over. So this yellow thing times this would make this. This yellow thing here times the 2 would make that. Now sometimes this here factors again, but in this case it doesn't. So that is the answer. That's not a difference of 2 perfect squares or anything, so we're done. This, however, is the difference of 2 perfect squares. This factors into x plus 3 times x minus 3. So when we look at the denominators here, they have to be the same. This one has an x plus 3, this one has an x plus 3, this one has nothing. Oh, this one has an x minus 3, but this one doesn't. So we're going to multiply the bottom of the fraction, the denominator part, by x minus 3. We do the same thing to the top, the numerator, x minus 3. Now we can multiply it out and simplify by subtracting the numerators. The denominator doesn't change when you add or subtract, does it? So x times x is x squared. This times this would be plus 2x minus 3x minus 6 minus x. All over the common denominator. This is easy to multiply back together, so you could write it this way, factored, or x squared minus 9. Okay, now we put together the like terms. We got a bunch of x's here. We have 2x minus 3x minus x. So we have 4 x's that are negative, 2 that are positive, so it'd be x squared minus 2x minus 6 over x squared minus 9. And this won't factor, because you can factor into 1 and 6 or 2 and 3, and that won't make a 2 in the middle. So there's no more simplifying after this. All right, on the back side, we're going to solve. Now when you solve, you have to worry about the solution at the end dividing by 0. So x cannot be 0 or negative 2. That's not part of the domain of the function. So negative 2 plus 2 would be dividing by 0, and then the same thing would happen here. So if those answers come up, then we are out of luck. We have to get rid of them because they'd be extra solutions. All right, so my binomials, I love my binomials. I'm going to give them a hug, so I'll put some parentheses around them. To solve a proportion, we cross multiply. So we get 3x plus 8, and then x plus 2. And then we're going to multiply these together, 3x squared. Now we just start foiling it out and getting an answer here. So this times this would be 3x squared. This times this is plus 6x. This times this is 8x plus 16 is equal to 3x squared. I kind of made it this way so that there'd be a 3x squared on each side, so it doesn't turn into a quadratic, because you're going to solve a quadratic on number 10 here. So these two go together, 14x plus 16 is equal to. Now if I subtract this 3x over, or subtract 3x over this way, they're going to cancel each other out, so it's equal to 0. Move the 16 over, 14x is equal to negative 16, divide by 14, and we get x is negative 8 sevenths. Sevenths is a really yucky decimal, so this one isn't a great one to change into a decimal. All right, the next one is factor, and then we set our factors equal to 0. 13 is a prime number, so it has to be 13 and 1, negative and positive. So we do 0 product property, and we make a t. We set each factor equal to 0, and we get x is equal to 13 and x is equal to negative 1. Notice I didn't have you do the quadratic formula on this. Okay, I added these two. This is the long division. So we get x squared plus 3. And we're going to divide that into x to the 4th plus 4x to the 3rd plus 11x squared plus 12x plus 24. So we got to make sure we line things up. That's the main thing here. We got to line up the x's with the x squareds and the x cubes and all that good stuff. So we pick something out, we multiply it out, and then we subtract it out. We always want to make it be the first term in the line so that it'll subtract out and go away. So I have an x squared. What do I need? Oh, I need an x squared. X squared times x squared is x to the 4th. This times this is not cubed, it's only squared, so we write 3x squared. All right, we pick up the red pen because I'm going to subtract. We subtract, we subtract. This goes away. This drops straight down. 4x cubed plus 8x squared plus 12x. We pick the next thing out. Well, I have an x squared. I need a cubed, so I need one more x, and I need a 4. So this times this is 4x cubed. That times that's 12x. All right. And then I pick up the red pen because I'm subtracting. Subtract. And then I get 8x squared plus, that goes away, drop down the 24. Then this works out evenly. I have an x squared, there's an 8x squared, so really all I need is just the 8, so plus 8. 8x squared plus 24. These are exactly the same, that's good. So when I subtract it off, it becomes 0. So my answer's up here. The answer to a division problem is called the quotient. So my quotient is x squared plus 4x plus 8. Rationalizing the denominator means that we are getting rid of the square root on the bottom. Here I have to multiply by the conjugate, which would be the square root of x plus 4, not x, square root of 3, square root of 3 plus 4. All right, these are like binomials. We love our binomials, so we hug them, give them a hug. So 2 times the square root of 3 is just 2 square root of 3. 2 times 4 is 8. So I'm just distributing through the parentheses. Now I'm going to multiply out. Square root times square root is 3. This times this is plus 4 square root of 3. That times that's minus 4 square root of 3. This times this is minus 16. All right, these cancel out, which is what I want to happen. I want the square root to go away. So I'm going to do 2 square root of 3 plus 8 over 3 minus 16. It would be negative 13. So there's the answer. Some people don't like the negative on the bottom of the fraction, so I'll multiply the numerator and the denominator by negative, making it negative 2 square root of 3 minus 8 over 13. So that would be an alternate answer, but there's no more square root on the bottom of the fraction. That's considered rationalized. So that would be like, you would be kind of looking at this and be saying, hey, why is this simpler? Well, it has to do with the olden days of not using calculators. And dividing by 13 is easier than dividing by that binomial radical expression. All right? Peace.